Factoring trinomials. So we learned how to FOIL, which is actually taking something in parentheses and making it come out in this form. So t squared minus t minus 30 is an example. Factoring is actually kind of the opposite effect. We're wanting to get it into those parentheses. So the idea is, this is your a term of 1, b term of -1, c term of -30. We're going to do what's called the AC method. So I take the a and c terms times together. 1 times -30 gives me -30. I then go about finding factors that multiply to equal -30, but add to equal my b term of -1. So -6 and +5 work. So what I then do is stick those in for b of -1. So here's -6t plus 5t. The interesting thing to know is here, if I were to add these together, I'm back to my original function. I haven't changed the function. I've just expanded it to 4 terms so I can now factor by grouping. Grouping in pairs of 2, pulling out what's common. This shares a t, leaving me with t minus 6. This shares a 5, leaving me with t minus 6. Since these are the same, they come out front. T plus 5 is left, and this is the factoring of this. Notice, if I were to FOIL this, I'd come to here. If I factor, I come to here. They're kind of the opposite effect to each other. Given a second function, a is 1, c is 32, times them together, I get 32. So factors times together equal 32, but add together equal 12. So 16 and 2 is an option. Nope, it doesn't add together to equal 12. 8 and 4 is an option. Yes, it adds together to equal 12. So that's what I stick in. It doesn't matter what order these are in, you'll actually get the same answer either way you go. So now at this point, we'll remember that with 4 terms, we group in sets of 2 or pairs of 2. This shares a w in common, so you're left with w plus 8. This shares a 4 in common, and I'm left with w plus 8. You actually will, if you've done it right, you'll always get to where these match. That's a good sign. If not, you should go back through and check your work. Pulling out the w plus 8 out front, I'm left with w plus 4 as my second term in parentheses. What if I was given m squared plus 12m minus 11? So AC is -11. Factors could be like -11, +1, 11, -1. Well, neither of these are going to add to equal 12. In this case, if you can't find, if all pairs that times equal this don't equal your mirror number, this is called prime. It cannot be factored. But say I'm given this, plus AB minus 20B squared. So AC equals -20, because 1 times -20 is -20. Factors could be 1 and 20, 2 and 10, 4 and 5. As long as one of these is positive and one's negative, you'll get a -20. If I want a positive AB, means my bigger number needs to be positive when adding. So I'm going to make these my negatives. To get a +1, I need 5 and 4. So a squared stays the same, minus 4ab plus 5ab minus 20b squared. 4 terms group in pairs of 2. This one shares an a in common, so I'm left with a minus 4b. Shares a 5 in common, a 5b, excuse me, a minus 4b. Now that they share the a minus 4b in common, that comes out front. What I pulled out is what's left in my second term. One last example. What if I have 5w cubed minus 40w squared plus 60w? Well, the first thing you could do is, well, what do they share in common? 5w. Pulling that out front, the greatest common factor, I'm left with w squared minus 8w plus 12. Factors of 12, because a times c, because we're just working on here, the 5w is just out front. We'll remember him in a minute. We could do 2 and 6, both negatives, to get -8, and timesing these together, you get positive 12. So I have 5w out front, w squared minus 2w minus 6w plus 12. Group in pairs of 2. 5w just stays on front for the ride. Out of the first pair, pull out a w, because that's what they share in common. Pull out out of the second pair, pull out a negative 6. So now they share this w minus 2. So the 5w stays out front. W minus 2 gets pulled out. And w minus 6 is what you're left with after you pull it out. So this is this factored.